The image on screen is a simplified model of the non-hierarchical structure of the smart grid. The basic principle of the smart grid is that it does not work in the standard hierarchical system that is currently used. It can connect to it, but is not bound by it. By working outside of this hierarchical method, it can save energy by supplying only requested amounts of power rather than the expected amounts, and it can heal itself in case of a blackout by rerouting power through other network substations. It also makes it easier to interface multiple power generation stations, including renewable energy sources that can be placed on an individual's house. These advantages, however, have a serious drawback. Each new element in the system is a new fault point. For the non-hierarchical structure of the smart grid to work is heavily reliant upon communication, much of which would be safer in a hard line. However, it is much more cost-effective to use wireless communication. To that end, they use Wi-Fi connections here, and here in the system to allow the smart meters, which allowed for two-way communication, to speak to the substation data concentrator, which allows the data from multiple area networks to be concentrated and sent back to the utility company, again via Wi-Fi. Or they also use SSL connections here to talk to third-party companies. All the security issues that will be discussed in this video relate back to the inherent problem of using a non-hierarchical system. Some of the attacks we will discuss include using data insertion to change the flow of power through the system to force an overload in one section of the system, such as inserting data here to tell it that the price is cheaper, or that that there's a blackout, so that the substation data will think that there's a blackout there or more price and drive it. Instead of going through this network, it drives all of it through this one. It can also be achieved by using a physical attack placed in the right location to take out this network. Lastly, the fact that the system runs off Wi-Fi can be attacked to gain information about the users through the SSL, the internet Wi-Fi connection to the data utility company, allowing them to gain secure information about the customer, or again, the Wi-Fi connections between the meters and the substation data concentrators can be attacked.
The U.S. electrical grid is spread thin across the whole U.S. and has hardly any thought to protection besides natural disasters. Thus, it is wide open to physical attack. The high-voltage transmission lines span the country with little defense. The thousands of substations are minimally guarded by chain-link fences, and the transformers only have basic metal containers, and the power plants are the only objects that have some decent security. The government has backed up and safeguarded strategic locations for war, but other than that, most of the country is vulnerable to long-term blackouts if only a few key components are taken out. The U.S. government is aware of the weakness and has been taking steps with the many proprietary components to fix the vulnerabilities, but it is going slow, and attack is always easier than defense. As you can see in this graphic, red dots are substations, and the many different color lines show the high voltage transmission lines. Key high voltage transformers can be taken out by merely shorting them with a conducting material. They can be shot with rifles to drain the coolant. They can be set ablaze with any means of fire and can be easily exploded with minimal effort. Weapons, fire sources, and explosives in America are legally and illegally easily obtained. Farming, fertilizer are not regulated too much and can be used for explosive, as displayed in the Oklahoma City bombing and IEDs in Afghanistan. The lack of guards and active security on all or many of the substations power lines mean unimpeded attack options. Reports state that as little as 9 high voltage transformers can be taken out to cripple the whole U.S. for a long-term blackout. Transmission lines can be targeted as well as generation centers easily with all the mentioned weapons as displayed here. Also, there's EMP, electromagnetic pulse weapons, that can be used, and they can be created cheaply with a car battery and a few components, and the grid is not protected against it. Also, a nuclear weapon exploded at high orbit can take out hundreds of miles worth the grid in electronics. Sorry.
So, a smart grid may employ dynamic power cost rate to discourage use during high demand times and encourage use during low demand times. That is achieved by using smart meters on every house, and the smart meters can control usage and demand. So, a meter can be told the current cost of the electricity at any given point in time. The power grid might use this type of dynamic power cost rate to make sure that they can meet the demand with their regulated supply. So a grid wants even demand throughout the day so that not everyone is asking for electricity at once. If everyone asks for electricity at once, then they won't be able to supply all that. So they want the supply and demand to be even throughout the day. This keeps the cost low, and if we regulate the demand, so we need the demand to be low as possible, so we can get that good price over here. So an example of this at work is what I've drawn out here. We have all these electric cars, and they charge at 20 kilowatt hours. This is what it looks like today. These are the charging capacities of these cars today. So, I mean, as soon as everyone in the neighborhood gets an electric car, then the demand is going to be wicked high. So, let's say that everyone wants to charge their electric cars when they first get home from work. That would tax the grid way too much because there would not be enough supply for everyone to pull the 20 kilowatts at the same time. So what the grid is going to choose to do is it's going to increase the cost of electricity because the demand is high over here, and it's going to say, hey, I mean, if you want to pay that much, you can, but the car owners, of course, want the best rate possible, if possible. So they're going to choose to wait until a less busy time to charge their cars. So one possible attack against this type of system is you can tell people, and their smart grids, their smart meters over here, you can be like, hey, demand's really low right now, and therefore cost is really low. You should totally plug in your car. And the user can choose, hey, yeah, I do want to plug in my car right now. But if I spoof this to this house and this house, I say, hey, and then all of these homes, and everyone's pulling 20 kilowatts because everyone thinks the demand is really low and the cost is really low, then you could spoof enough people into using enough electricity to shut down the grid because there's not going to be enough supply. So that's availability attack. There's another attack that these people are getting their wallets hurt because they don't know they're going to be charged the excess amount of money. So that's an integrity attack because someone's going to be modifying the data to break the integrity of the costs here. So there needs to be a system in place where the users are protected against accidentally asking for too much electricity at any given point in time to keep demand low.
Hello, my name is Mike Stoic, and I'm here to talk to you today about wireless data attacks on a smart grid. In the background, you're going to see an application that I use, something called Aircrack and Wireshark. The reason I bring Aircrack into this discussion is that because it's been around for several years now as an open source software that is able to crack wireless networks. In the future, all devices are going to be on the internet. Now, wirelessly, it'd be a lot more seamless than you carrying a wire every time you want to plug something in. Now, with things being wireless and we have so many phones today, Androids, iPhones, Windows Phone, everyone's going to connect. Now, with that connection, with the software in the background, you can actually wait and sniff traffic, inject traffic, or just passively monitor everything. Now, it's a possibility that while you're waiting for this traffic, one of these engineers is going to try to connect with the device. They're going to capture that WPA handshake. Now, with enough knowledge and enough power, you're going to be able to possibly get the key in that handshake and actually authenticate to that network. Once you're authenticated, you can just sit there passively, wait for all traffic to do some analysis to see what's going on, or you become malicious. Now, knowing what this traffic is, you can say one neighborhood is not using much power, let's just not give them that much during peak times, when really they really need it. I mean, another example would be that if you want to save on your electric bills, you want to save that extra $5 a month, you can just modify these meters so that it reports a lower one. Or you can also say that you're putting more power back in the system and actually get some money back. Other malicious things you could do with actually once authenticating this network is that you can destroy equipment. Knowing the actual traffic flow, you can, let's say, push more power through older equipment, causing thousands of dollars of damage. Now, these huge substations are very expensive. They'll take months to replace some of the hardware there. So just pushing, 10 times the amount of normal power through it would drop a small town or a region, or even more depending on how malicious they want to go. Another thing they could do is, let's say for malicious lobbying. For example, is that if a particular person, political reasons, wants to become in power, let's say they're able to stop the power consumption in a particular neighborhood so that those particular residents become a little more vocal and aware of the political things in there. He's able to get a little more attention, saying that he's going to try his best to improve the infrastructure that's currently in place. You can also, sit there passively. So, one example is that while some peak hours, you're just going to slowly trickle energy to other locations so that you yourself would gain, yet again, saving money. Another example is with the Stuxnet. It was a genius software, but what it did is that it's made the centrifuges spin slightly faster. In layman's terms, it made it do slightly faster, going above what it recommended. Now, that for months, years, slowly damages the equipment, but almost seems like nothing's there. So if we were to use this, let's say, on these huge infrastructure, these huge subplants, this for a couple months slowly give it more and more power, but with this data you collected previously passively, you can fool the network into believing that it's just normal traffic. So as the days and months go by, slowly your things just start dropping here and there, but there's no reason because your traffic seems like it's all right. So if you let that go for months, years, slowly you can have all your equipment starting to just die. Now it takes months to replace this. So I mean, with that knowledge, you can cause huge headaches or even yet again political gain. If you know that in 6 months' time you're going to need 1,000, different little parts, why wouldn't you invest in that particular company that makes it?